Okay, let's try to understand the formula for the angle between the two lines. Now, let us assume that these two lines intersect each other at an angle other than 90 degree. So, if these two lines intersect each other, then we get two pair of angle. One is the angle that is obtuse angle, and other pair will be the uh, obtuse angle. This will be your acute angle, and this will be your obtuse angle. You know that these two angles are linear pair of angles, so they are supplementary. So if you are knowing just one angle, then also you can find the other one. But here particularly the formula which you will see will give you the acute angle between the two lines. Acute angle, be careful. The formula will give you the acute angle between the two lines. If you are interested in finding the obtuse one, then you just subtract the acute angle from 180, you will get the obtuse one. But the formula will give you just the acute angle between the two lines. So we will assume that the slope of one line is m1, whereas the slope of another line is m2. Then the angle between two lines can be found out using the formula tan theta is equal to modulus m1 minus m2 upon 1 plus m1 into m2. So you can see that if you are interested in finding the angle between the two lines, you should know the value of slope of that two lines. Means you should know the slope of two lines, right? This is how you will find the angle between two lines. Uh, Now, we will use this concept to find the collinearity of 3 points. So, condition for the 3 points to be collinear. Now, collinear means this all 3 points will lie on the same line, right? If 3 points lie on the same line, then I can say that these 3 points are collinear. So how to check whether the three given points are collinear or not? Then you simply apply this concept that slope of AB, that is you find the slope of AB and you find the slope of BC, and if you get the value of slope of AB and BC as the same, then this is proved that these 3 points are collinear. We'll start with the very first sum of your exercise 10.1. Here, draw a quadrilateral in the Cartesian plane whose vertices are given, and also we need to find the area of that quadrilateral. So we can see that the vertices of quadrilateral are minus 4 comma 5, 0 comma 7, 5 comma minus 5, and minus 4 comma minus 2. So you have to estimate that in x-axis you have to go till -4, whereas for positive you will go till 5, right? So you have 1, 2, 3, 4, 5.
सर ये ग्राफ बुक में ही करना है ना?
Got this? Right. Uh, in y-axis we will go till -5, that is -1, -2, -3, -4, -5. Whereas in positive we will go till 7. 1, 2, 3, 4, 5, 6, 7. 0, comma 7 will be over here. -4, comma 5 will be somewhere over here. 5, comma -5 will be over here. And -4, comma -2 will be over here. So we'll join these points. So this is my quadrilateral form. Now they are asking us to find the area of this quadrilateral also. Also we'll name this first of all this as A, B, C, D. Now you can find the area of this quadrilateral by taking one of the diagonal. You are free to take as AC also, and if you are free to take as BD. Here I will select BD. You can see that my quadrilateral is divided in two triangles. So the area of this quadrilateral will be the area of triangle ABD plus the area of triangle BCD, and finding the area of triangle is uh, by applying that formula half x1 y2 minus y3, right? So area of triangle ABD is half mod x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y. This is your formula. Uh, so I will take this coordinate as x1 y1, this as x2 y2. For this will be my x3 y2 -4 comma -2, right? So x1 y2 minus y3 plus x2, as it is 0, will not solve because 0 multiplied by anything will be 0 only. X3 y1 minus y2, minus minus plus, so 9 4 are 36, and this will be minus minus plus 4 2 are 8. The answer will be 28 minus 28 for 2. Right. Now, area of triangle uh, BCD. Here I will take the coordinate of C as x1, y1, whereas B and D already we are having x2, y2. So this will be my x1, y1. So half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So half x1 is by y2 minus y3 plus x2 0 multiplied anything is 0 and x3 y1 minus y2. So this will be minus minus plus 55 minus minus plus 48. So this will be 4 is 8, 6 are 12. So this will be 26.5. So area of quadrilateral ABCD is area of triangle ABD plus area of triangle BCD. So 60.5 square units. This is the area quadrilateral ABCD. Okay, let's try to understand second question. The base of an equilateral triangle with side 2A lies along the y-axis such that the midpoint of the base is at origin. Okay, so we'll draw one Cartesian coordinate system. This is my y-axis, this is my x-axis, and side is on y-axis such that the midpoint is the origin. So if the length of this side is 2a, then definitely this will be 0 comma a and this will be 0 comma minus a. Let us assume that the third vertex lie on the x-axis, and it will lie on the x-axis. The reason for that I will explain you. Will explain. See, as it is said that the midpoint lies on the origin, means this will be the altitude of the triangle and also the median. You know that if your triangle is equilateral triangle, then the altitude is in only your median. As this is the median, you can see that this is also M, this much is also A. So this line will be the median of equilateral triangle, and it is also the altitude. So definitely your third vertex should lie on this line only, that is your x-axis. So your point will be either on the positive side of the x-axis or negative side of the x-axis. You will assume that the coordinate of the vertex C will be x comma 0, right? So let the coordinates of vertex C be x comma 0. This x can be positive or it can be negative. and accordingly it will be there on the positive side of x-axis or either negative side of x-axis. Coordinates of vertex A and B that we already found out using the given conditions will be a comma 0 and sorry 0 comma a and 0 comma minus a respectively. Now the length of side is also given that your AB is 2a, so that AC and BC will be of the same length. Here we are asked to find the vertices of a triangle. So we have A and B. We just need to find the value of x so that we will get the third vertices too. Now, if you will observe triangle AOC, AOC, then this is 2A side of the equilateral triangle. This is the median, that is the A, and this much is x. So OC is x, as your coordinate of C is x. So applying Pythagoras theorem, AC square is equal to AO square plus OC square. So 2A whole square is equal to A whole square plus x whole square. So x square will be 4A square minus A square, 3A square, and therefore it will be root plus or minus root. So vertices of equilateral triangle will be 0 comma a, 0 comma minus a, and plus minus root 3a comma 0.